Okay, so open your notes for yesterday. Yes, we're going to take your notes today. We're going to review from yesterday first. Well, we took notes on Tuesday, so open your math notes. Yes, the topics 1 through 5. Okay, so we've got number types, order of operations, imperfect squares, scientific notation, and ratios and proportions. All right, give me some review. What do you remember about number types? Okay, so tell me again. Whole numbers, natural, integers. Okay. Okay. What number or what category do all numbers fall in? Good. Are all numbers real? Can you think of one that's not a real number? Okay. So whole, natural, integers, rational, irrational, and real. Okay. Good. So all real numbers. All numbers are real numbers, right? Okay. What are the difference between rational and irrational? Repeat or stop. It can be one of those, right? Okay, so rational repeats or stops. Good. So it's the opposite of this, right? It does not repeat and it does not stop. So it goes on forever. It goes on. Good. Forever. Does not. Okay. So let's talk about these. This one should be pretty easy. It's counting numbers and zero. Good. So counting numbers and zero. Good. What about these two? Okay, so natural numbers are the same as counting numbers, right? And remember that you can't ever count zero. So it's not like I say, here, count these pennies. You go 0, 1, 2, right? Okay. So natural numbers are just the counting numbers. And no zero. Good. Are they fractions? Are they decimals? Okay, so they're only negative numbers, positive numbers, and zero. Very good. If I was going to make this like a Venn diagram with all these topics, okay, so let's talk about what are all numbers? Real. Okay, so if you're taking notes, which you should be, draw a big circle. Yep, on the same page. Put real on the outside. So all numbers get to be real, right? Okay. What is the next set or the next biggest circle that I can draw in there? So are all numbers, most numbers whole? So that would be the next biggest group? Integers. Integers have positive and negative, right? Whole numbers doesn't have negative. So this is a pretty big group. What about these two? Aren't all numbers either this or this? Okay, so I made a mistake. I'm going to make one big circle and one little circle, but I need them both to be in real. Okay? So after you draw your big circle for real, I want you to draw one big circle inside and one little circle inside. So here's watch. Here's my big circle inside. Here's my little circle. Okay? Big circle inside, little circle inside. Which one, rational or irrational, has a bigger set of numbers in it? Rational. Very good. Yeah. It's harder to find an irrational number, right? Okay. So let's put rational here. Oh, irrational. And rational on the big one. Not yet. Yes. Okay, so we took care of rational and irrational and real. Where do whole, natural, and integers fit? Integers is next because it's bigger, because it has positive and negative. This one doesn't have negative, right? And this one doesn't have negative, right? Okay, so draw another circle inside rational. And what are we calling it? Integers. Right. We're done with integers. Now, which group is bigger, whole numbers or natural numbers? Whole numbers, because it has 0. Does natural numbers have 0? Okay. They're almost the same though, right? Okay. Right. One has 0, one doesn't. Okay. So we need one circle there, and then one more little circle inside. Okay. All right. So which one is bigger, natural or whole? Right. Because it has 0, right? Okay. Whole. And then what's left? Natural. All right. Give me an example of an irrational number. Hi. What does sky look like when you write it? 1, 5, 9, 2, blah, 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 blah. On forever, right? Okay. So 3.14, blah, 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 blah. Could you make up a random irrational number? Yeah. It just has to never repeat, right? And it should end with dot, dot, dot. Can it have a bar in it? No. What does the bar mean? Good. All right. So irrational numbers can't have a bar on them, right? Okay, so let's just make one up. Let's say 12.1846205. Totally random, right? Okay. So make up one more irrational number. Play your circle. All right. Back to natural numbers. Aren't those just counting numbers? So let's just put 1, 2, 3. 1, 2, 3. It doesn't have to be very big. Okay. All right. Okay. What is the next thing I can put in the whole numbers? 0. Right. Do I have to put 1, 2, 3 because I already have that circle inside? No. So I can just put 0, right? All right. So whole numbers get to 0. Add it to it. What does integers get added to it? Negative numbers, right? So add some negative numbers. So let's say -6, -2, -4. All right. What about rational? What can I include in rational that I didn't have in integers, whole numbers, or natural? Fractions. So let's do 2/3. Let's do. Yep. Rational is the only one that accepts fractions. All right. What else can I fit in that category? What goes with fractions? Decimal. All right. So let's put 0.25 and 8.7 and -3.6. Are there any other numbers that we didn't write down that can still fit inside this giant wheel? A repeating one. Okay. I could have put that in there though, right? Okay, let's put that in the rational one since they can repeat. Let's do, how about 0.444 dot dot dot. Okay, we do negative decimal. How about -0.71 bar? Is that good? Okay. Drop down. Okay. So now let me ask again. Are there any numbers that we didn't talk about that can still go in this big circle called wheel? We talked about fractions, decimals, whole numbers, counting numbers, negative numbers. Ratios are like fractions, right? Okay. Well, good. I can't think of anything right now. I'm sure if we really thought about it, we could probably think of a couple, right? If it was in this circle, you'd still have to be able to tell me if it was rational or irrational, right? Okay, making sure. Good.